So first thing I have to say is I'm sorry for the accent. You just have to get used to it. Hopefully by the end of the talk that will be okay. And the second thing is I'm not Christine Jones, just so you know. Okay? And a lot of the people I've been visiting in the US have been almost following in the footsteps of Christine. I actually hang out with her a couple of times as well. And so it was pretty cool. Okay, so this is the kind of stuff that we all resonate with. Kaya mata mato te tupu atane arongo ha homia tike tike. Let it be that the land and its fruit may flourish. Right? You want to do that? Yeah. I think this is where we are really. I'm just going to give you 2 seconds to read it. I don't think I need to comment very much. We don't have that much diversity. This is what's happening. Okay, so I'm just going to go through what is this diversity thing that everybody's talking about. So there's actually quite a lot of science backing it up that diversity is important for the functioning of the system. So it's a beautiful experiment that was done by scientists in Germany. It's still running. It's, I think, now 18 to 20 years running. And what they've done is you look at it from the air. All of the little plots are different number of species. And so they assemble these communities, manipulating the diversity. And if you let me go closer, that looks like this. So it's small scale, typical scientific experiment. And you have between 1, which is a monoculture, up to 60 species. And they looked at how that affects the functioning of the community and the system. And so what they found is that as you increase your number of species, in blue you increase your water infiltration rate. In yellow you increase your soil porosity. In green you decrease your bulk density, so your soil becomes lighter. And then you increase your soil carbon storage. And all of these results were highly significant. They looked at this when they observed their system for about 10 to 15 years. And so what does it mean in practice is that when you increase the diversity of plants in your system, you increase all of these things that are very important to have really good functioning of your system, high production. You can retain your water, you avoid flooding, you avoid drought, all of these things. And then they also looked at other aspects of the system, and as you increase the diversity of your plant, you also increase the number of pollinators and the diversity of those pollinators, so you increase your chance of getting production, flowers, etc. And you also increase the amount of pathogen resistance. So there's all benefits to have a diverse system. Right. So let's look at what that means below ground, because really everything that supports the health of the system comes and stems from the soil. So I do a lot of that stuff actually, that's my work. So this paper just came out, literally was published 3 days ago, and it's super crazy stuff. So some scientists have looked at 5 different systems, so from top to bottom, basically they've manipulated the amount of diversity, different type of plants and different number of species put together. And then they've taken loads of cores, which they sliced every 2 millimeters, that's a bit crazy. And then they did some fancy stuff with imaging of enzymatic activity and using, am I okay with this? Tomography, yeah. So X-ray. And they overlapped the result from this and made some 3D models. And I'm just going to summarize what they found. So on your left, so here, you have your system which is not diverse, so a monoculture. And on the right, you have your system which is diverse. And what they found is in your soil, when you have an increased diverse number of species, you have more pores. These little things are pores. They are about 30 to 150 micron. And this is where there's the highest activity of microbes. This is where the carbon is pulling from the plant. So what happens is in those pores, your microbes chew the carbon. It's like the liquid carbon pathway that Christine Jones talks about all the time. But then they figured out that the enzymatic activity, everything's happening with the microbe is only restricted to these pores, And then the carbon moves into this space here, and it's stored. And so it cannot be accessed, it cannot be respired. So the more you have plant species, the higher number of plant species, the more you have these spores, the more you have carbon coming down, the more some of that carbon is put in this space and stabilized. Make sense? Yep. Cool. So, I talked about the plants, now what's happening with the animals? So, animal is something that I have very little comfort in talking about because I know very little about it. So I'm just going to defer to one of our colleagues, Pablo Gregorini at Lincoln Uni, and Fred Provenza, whom I'm sure a lot of you have heard of. And basically this is the latest model they came up with. So when you have a system that is diverse at the very top, you have loads of different plants, they all have different compounds, different molecules in the plants, different type of nutrients, and your health is high. The health of your animals, the health of the humans that eat the animals. If you decrease and you simplify this system, which is what most of the current productive landscape is doing, when you have a lot of monocultures, or when we humans use very highly processed diets that are very simplified and we eat always the same thing, all the health is decreasing. So I'm not going to show you any data for that because the scientific community is still constantly trying to find this link. So, you know, they have to absolutely find the proof that if you remove one, then something happen or not happen. And most of the science is based on a reductionist approach. And this type of system are very difficult to demonstrate taking a reductionist approach. So there's still a lack of data to absolutely demonstrate the link between the diversity of the forage to the animals to the health of the humans, but it's sort of common sense. Yeah. Okay, so this is all cool talking about this diversity stuff, but we need to make money, right? So you want to plant a diverse system, but you still want to make sure you keep in business in your farm. So there's been a really nice study that was conducted by Dr. Jonathan Lundgren, whom most of you, or some of you met last year because he visited New Zealand. And what they looked at, him and a student of him, they compare corn that was grown regeneratively or conventionally using best practice. And they define regenerative farming in that situation when there was no use of insecticide, no tillage, sometimes there was integrated grazing, and between the corn rotation there was multi-species cover crop. And in their conventional farms, the corns were neonicotinoid treated, they didn't use cover crop, they didn't have animals in the system, and most of them still used tillage. And that was done in the Midwest of the United States. And what they show is that, I want to draw your attention, this is the revenue and the cost, so how is that system looking in terms of dollars? All of these different boxes in colors are the size of how much it costs them to do whatever, use fertilizer, irrigation and so on. And what is white is the profit that was left to them. And you can clearly see that when the corn was managed regeneratively, there was a greater profit for the farmers. Now, that's not all, because they also looked at the pest abundance. So even though in the conventional corn planting, the corn were treated with neonicotinoid, they still had greater pest attack compared to the regenerative ones. And so what they tried to do as well is look at, okay, so what is the indicators of the system that are really explaining what's going on. And so they looked at the soil bulk density versus the profit and the organic matter. And this is really showing how important the structure of the soil is. As you decrease your bulk density, so your soil becomes lighter, you're more aerobic, there's more pore, there's more space for the water to infiltrate, you increase your profit, and you increase your organic matter. And that's a really neat set of data. Okay. So behind this work, here I want to point out John and some of his students whom I visited when I visited them in the US. And the reason why I want to attract more attention to him is that we're here because we're all people, and each of us have a story. And John told a bit about that earlier. And the same apply for the scientists and the non-scientists. And what I've been doing really in the US is talking to people, hearing, understanding what they are doing, the space they function from, and their story, and how are these different stories contributing to the diversity of the actions and the state of being we can take if we want to manage our landscape in a way that is more sustainable and resilient, and so that we are happier. So Jonathan did a lot of research on the impact of neonicotinoid on insects, and was finding that the more it went, the more it was difficult to publish because his findings were controversial. And so what he did is he left the conventional academic system, and all of his research is self-funded, not self-funded, sorry, philanthropic funded and crowd-funded, so he's completely outside of the system in the US. So it was really interesting to hang out with him and understanding how he works. So really what I want to point out is that the diversity, we were talking about diversity in those systems, and I've just highlighted, it's a diversity of stories, diversity of approach. So I'm still in the conventional academic system right now, and Jonathan is outside of the academic system, and there's two different ways of doing and going about things. And what's really beautiful is if we can all contribute from where we are at to make the story better. Right, so I want to take you to tell you another story, which is in Dakota, which was not far from Jonathan, actually 6 hours only. And I want to talk to you about the Dakota Lake Research Station. This is the kind of landscape that you see. So it's completely flat, and you have pastures, or you have corn or soybeans and wind farms. And that's for hours and hours and hours. That's the landscape. And so when you arrive at the Dakota Lake Research Farm, you see this sign, this is what it looks like. And just to put it in context, so a lot of snow, a lot of rain, high temperature in the summer, and low temperature in the winter. The farm was founded in 1990, and it's basically a farm that is run and governed by farmers, but it's fully inserted in the mainstream system. So it's trying to make change. It's trying to make change within the normal production system and refining it and making it more sustainable. Its mission is to research and demonstrate how to stabilize the agricultural economy, increase diversity, and minimize the negative impact. And this is Dwayne Beck. So he's managing the farm, and he's part of the Notill on the plain. I'm sure that some of you have already heard of him. He's doing a lot of conferences and podcasts and so on. And he's got a lot of charisma. And it was really, really, really amazing to spend a few hours with him. One of the two sayings he's known to say on a regular basis is that it's time we take the E out of E.T. and the T out of can't. And so basically what it means is we know more about Mars and the Moon than we know about the soil, and perhaps we should shift the focus on understanding how our planet works. And if we want to make progress, we really have to overcome this mindset that things can't be done and things are impossible, like it's impossible to store carbon in the soil, for example. Maybe we have to overcome that mindset. So how is Dwayne working? Dwayne's working within the system in close partnership with universities. So that's when I visited an example of a field trial with an agronomist testing several varieties of canola. Here is trying to optimize companion cropping, so you have peas and a cereal together, so the cereal is supporting the peas, and he's trying to figure out how to do that in the best way within the normal system. Here he was trying to optimize inter-row cropping with core. And one of the things I learned when I visited, which I was very surprised about, is North America actually has almost no native earthworm species. They were killed 10,000 years ago during the last ice age. And so Dwayne figured that out, and so he introduced these earthworms that form these very, very deep burrows, so they go down to about 1 meter, and that's a way of aerating the soil. And we just, after the second time that we put the spade in the ground, we actually were lucky to find one of the burrows here. You can see the hole. I was really excited. And then the other thing is Dwayne is always thinking in terms of a fall system. So a lot of the properties I visited, people were complaining about the rodents or some of the mammals that were coming and destroying their crops. And in this area, no exception, there are what they call the prairie dogs that come and just wreck around and cause havoc on the properties. And Dwayne observed that the prairie dogs never go in the high vegetation, because then they can't see the predators coming for them. They can't see the coyotes. So what he did is he planted a row of, here you can see this strip of native grasses throughout. So the entire farm, research farm, is surrounded by this strip, and it's enough to keep all the prairie dogs out. Whereas all the neighbors are still struggling with them. It's sweet. Okay, so what I want to really, why I wanted to tell Dwayne's story so much is that he's been working with universities and natural conservation agencies in the US, and so they've really monitored what was going on. And basically around him, this is when the station in 1990, you see here plotted the time, and on the y-axis you have the number of acres, so the surface area in the state that is converted to Notill. So when they formed this research station, there was hardly any no-till practices in the state. And from 1990 to 2015, which is the last time they recorded, there was a steep increase of adoption in no-till and decrease in conventional tillage. So his vision, at the time when he started that, it was unusual to do no-till. It was over 20, 30 years ago. His vision and his determination and the way he was going about it, that was just one man with, plus a few people supporting what he was doing. This was the effect that it caused. And so that's really making the point that one man can change so much. Okay, or a woman. Okay, now I want to take you to California and tell you a different type of approach to how we can make things better. So California, I found out, I wasn't very aware of it. So New Zealand is the 53rd wealthy country in the world, right? We're doing pretty good. California on its own, not the United States, is the 4th wealthiest. Yeah, so that's like a really large economy. In California, 9 out of the 10 highest producing counties are found in California. So these guys are growing a lot of stuff. Okay, and when they are growing these stuffs, why? Because they have a lot of sunshine, but they're starting to run out of water because it takes a lot of water to grow all the stuff they have. And in fact, the sunshine is also, I was driving past all these orchards and I was going, what's this white stuff on the leaves? All the trees that were on the side exposed to the sun had these white things. And then I asked the guys over there, and basically the sun is so strong that they have to spray some stuff as a sunscreen protection on the leaves. So this is the kind of constraint they have, very different from where Dwayne was. And then in there, there's a huge demand for organic produce. So I ate a lot of those. They are dandelions, $4 for about 5 leaves, right? A lot of money. Okay, so the this what I discovered there. When I set off to the United States, I was coming from a place where, you know, in New Zealand and in Australia, I work a bit in Australia, there's not a lot of poor extension system, and it seems that there is quite a disconnection between the farming community and the scientific community. And what I found in California is this is not the case, and I want just to tell the story of two institutions that are really supporting the farmers. So I met with Jeff Mitchell, who is at UC Davis, and I met with Cindy Daly and Tim Lazar, that some of you might know of, who have founded the Center for Regenerative Agriculture and Resilient System in Chico. And so they are both universities, and they're both basically working to empower the farmers and to support farmers innovating. So they are not driving an innovation, they're just helping the farmers innovate and pass on that innovation and diffuse the information. So they are working with farmers mentors and farmers networks. And what I did is I actually went to visit one of these farmers, so Phil Foster. It was a really nice time as well. So Phil, what's happening is that in this area there's a problem with the water, and their soil are quite low in carbon. So when Phil started growing organic vegetable and fruit about 20 years ago, he increased the diversity of his system. It was organic production, but he managed to manipulate in plant diversity to increase the soil organic matter from 3% to 6%. And then, for 10 years, no matter how good his practices were, the soil carbon wasn't increasing. And because it's so key to retaining the water, it was really, really important that you try to increase the carbon. So what he's doing now is with about 10 other farmers, they are trialing all sorts of different things, teaming up with the scientists and having constant feedback about ideas. How can they increase the carbon more by using no-till in an organic system, which I know some of you will know that's a real challenge. So no use of herbicides, none of this stuff, and no-till. And so this is, just to confirm the context, this is one of the fields that Phil had just harvested. It's clear that there's an issue with water, right? This I visited just early July. Okay, so I want to show you a few of the things that Phil has been trying to do to optimize the use of water. So do you want to do the, because I think that's where we'll have to film, yeah. So what is done is using cover crop to increase soil carbon and soil health, and is planting these cover crops in a way that it optimizes the amount of water that it puts a small irrigation line. So if you were doing it really on the optimal irrigation for your cover crops, you would have more irrigation line. Is decrease it to the bare minimum to make sure that there's enough growth so the root grows laterally next to along the row. Next one. Then Phil is the one that has done the most successful roller crimper trial. So here, I'm sorry there's no sound, but it was explaining basically this is a field of melon. They had melon, and then they harvested the melon, and they went with the roller crimper. Do you know what is a roller crimper? No? Stop. So the roller crimper is a machinery that you use where you snap the top of your vegetation, and you have to do that at a particular stage of your plant growth. So you terminate the vegetation without having to till the soil and without having to use herbicide. And it's really tricky because if you arrive a bit too late, your plant will still have put some seeds, and then you have the seed coming the following year, or you might just break them but they still regrow. So it's like it requires a lot of optimization. And so Phil is the one that has managed to optimize that the best. Another thing that he does in his system is he uses compost and compost teas. So, and this is a compost turner. And again, they're optimizing, they've got to rehydrate that compost on a regular basis. So he's optimizing the ways they're putting water, which is in short supply. And he's just misting that compost.
Where do they get the compost from?
So he's sourcing the compost from some of his local material. and then there's a local supplier of a compost feed that is tailored to his particular requirement. So he's very particular about the way he does the compost. And I didn't take a photo, but he's also got 2 massive tanks in which he's doing his composting. Yeah, really nice. Great, and then this is probably my favorite. So all over his farm is planting what we can call a pollinator or a pest control bank. And if you look at how this stuff is buzzing, there's loads of insects. And this was at the height of the day, so I think it was probably 2 or 3 in the afternoon when I took that video, and usually everything shuts down because it's so hot, but this was working, really buzzing. So here you go, that was the story of Phil. Now I want to tell you about another approach, and a completely where you've got completely different problems. So this is in Colorado, and it's in the San Luis Valley, which is next to the Great Sand Dune National Park. So you see the sand dunes here, like it takes about a day if you want to hike from one to the other, so it's quite big. And it's a valley which is basically the coldest desert, highest cold desert on Earth, and it's a steppe. So steppe system, very, very, very special. This is what the valley looks like, and so very, very special plant community that are adapted to this environment. Obviously, it gets really cold in the winter, and they have a huge problem with water because basically they don't have a lot of precipitation. And all the water that they get in the valley comes from the snow in the mountains that feed into the aquifer that you have here on the ground. And the valley is the home of about 45,000 people. And what's happened is that they have managed to optimize agriculture in this environment. And so grazing and potatoes and some cereals, and they have started to exhaust the aquifer. And so the government has given them 10 years to sort themselves out. And if in 10 years they haven't managed to change their practices, they are going to shut down agriculture in the area. So you have 45,000 people. Each of them have got an idea of how things should be done. And if one person doesn't comply, that's the effort of all the others being annihilated. So it's a very interesting place to visit because for me it's almost like a microcosm of what's happening with the planet, right? So I met Patrick ONeal, and again, he's an academic that has stepped out of the academic system. He's got his own company and he's working with farmers, doing his own research and advising the farmers. And he's doing a lot of social work, and his groundbreaking idea is that maybe to help with water retention and to prevent farmers from having to pump so much water but still producing food, he could use the Johnson Sioux compost. You guys familiar with the Johnson Sioux compost? Yeah, and not, how many are not? Quite a lot. Okay, I'll just run it through very quickly. So Johnson Sioux compost is a way of composting where you're increasing the proportion of fungi in your compost compared to bacteria. If you have more fungi, you're promoting the storage of carbon in your soil, as opposed to just chewing up the carbon with respiration and chucking it back in the atmosphere. And the way we think this compost works is by increasing this quorum sensing. So totally appropriate for the talk today. And basically, the compost concentrates the amount of signal molecules that all the microbes produce, and these molecules are like a symphony of words and communication between all the different bugs and microbes that live in the ground, in the soil. And when you put that compost onto your soil, it's almost like a switch that you turn on. And it's not just really about just adding more bugs in the soil, it's about adding the words that the bugs speak to other bugs. and it gives the signal, turn on. So it's, there's a lot of research. I would love to do so much research on that. So if you have any money to give it, give me that. Thank you. So the way that Johnson soup compost is done is usually in very small scale. And David's decided he's going to try, and Patrick has decided he's going to scale it up. Can you see the size of this, right? Now, I know Simon and Sam have been building some, yeah, and so this is pretty challenging the way he's doing it. And his idea is that he's going to produce that compost, then do some extract from it, and he's going to test it with different farmers. And he's doing that with high visibility in the community. So he's getting people together to discuss the issue of soil management, increasing efficiency of water usage, and how we can work together. So it's in a way it's an ecological and a social experiment to see whether we can sort out the problem in the valley with the water. Okay, I'm just gonna get that through. So what I've touched down a bit is I've showed you different way of going about things. But basically all the people that I've visited, they had a kind of a different mindset and different type of values than the mainstream around them. And so where I've been doing a lot of thinking for myself as a scientist is if I want to help you guys, you know, make progress, I also have to change the way I work and the way I do my science. And my mindset to it, and the way I observe reality, and the way I interact with my colleagues, right? So last year we were thinking about what could we do as researchers to help you. So we invited a few of you that are here, and we hosted a workshop with Sam, and we had a brainstorming about how would we need to look at the farming system and at our values for us to turn New Zealand into a super green, sustainable, resilient, happy place where everybody produces good quality food, wealthy, happy, connected. And so what we found is that what was important is to start looking at things. The soil was obviously quite essential, but also systems, system, system, system. So reductionist approach, which is the kind of science I'm used to do, it's not really working to look at systems. And the other thing we found out is that we have to take into account whether we can still be profitable, but there's a lot of really key values such as communication, how we are connected with each other and with the landscape, how we identify, you know, what is our identity, and whether we are balanced. So how do we do this? So to do this, at the center is what's happening on the farm. But as you know, the farm is influenced by all sorts. So when we are thinking about what we can do to help, we have to think at the entire system, the entire food system. So that goes from finance, tool and service providers, even researchers, educators, your retailers, your consumers, your regulators, governmental bodies, philanthropists that give you the money, and storytelling. And so I met David Hodgson in California, who's a guy who's basically doing thinking all the time and connecting with people and trying to empower anybody who wants to create a change, to create a more sustainable planet. So we put this stuff together, and what I want to show you, there's all these words, you don't need to read them. What I want to show is that every place of this big system, there are things happening. So even though some of you might feel that things are not moving fast enough, that maybe you are isolated, I certainly sometimes feel isolated, it's not really true. There are loads and loads and loads of people that are wanting to make a change. And here I've mapped all of the initiatives that I'm aware of, and worked a bit with Sam as well, and with David, in all of the different aspects. Now, all the ones that are bold are the ones that have a reach out to New Zealand. And you can have this material afterwards and you can look up on the internet. So you see there's quite a lot of bold in New Zealand, right? So New Zealand's not isolated, there's loads of stuff happening in New Zealand too. And then here I've mapped in red all the things that we are connected to and we started to work with, all the initiative, all the people, all the organization. So this is really to tell you, there's a lot of stuff going on, yeah? And at the center of this, there's Quorum Sense. And thank you.
Does anybody have any questions for Dr. Grelet? Nikki?
Yeah, going back to the early part of the presentation and looking at the German experiment that they've been running for 22 years, have a lot of the farmers picked up on that?
In Germany? I would say yes, and probably no as well, both, a little bit like here. There's, if you look on the press, there's a lot of emphasis and focus on agroecology, which is really what this is about, increasing the diversity and harnessing the biological power of nature. Germany, France, UK, it's going big time. Yeah. Yeah.
Chris?
Oh, I was just saying, can you repeat the question for people?
Oh yeah, okay. So the question was, have the farmers picked up on the outcome of that experiment?
In Germany.
In Germany.
Germany.
Yeah. Germany. Yeah. Any other questions?
Okay. We've seen a lot of countryside. Like, how long have we got until we actually, you know, some of us are aware that we really have to crack on with our carbon, and so it's declining in the world, but how long do you think we actually have?
I'll show you this one. Okay, so shall I repeat your question? Your question was basically how long we have, yeah? If we don't change. So the models about 3 or 4 years ago were saying something like 20 years, and then the models last year dropped down to 12 years. So this is what's driving me. They are only models. So I think we, as a scientist, have to say that all the time. It's only models, it's only a prediction, and the models can get it wrong, right? Because we don't know everything and we can't measure everything. But this is cool work that's been done. It's the concept of planet boundary. So what it means is that you have for every system, your system is going along, and then things don't go very well, but the system is still coping, and still continue not to go very well, and your system is still coping, until it reaches a point, a threshold point, where it can't go anymore, and then things degenerate very, very fast. And so this team based in Stockholm, and also working with people in Stanford Woods in the US, they've looked at the different type of boundaries that we have on Earth, and they've, in red, the boundaries where they think we are beyond that threshold. So climate change, they think that we've exceeded the boundaries. Biodiversity, land conversion, and how we lose nitrate and phosphorus, and how much we load and then lose it into the water. So I did a lot of traveling, so I expended a lot of carbon in the planes, and I always have that dilemma. What is the best thing? Is the best thing that I stay here and I don't consume carbon, or is the best thing that I travel? And I think everybody always, you know, if you start thinking in those terms, every day we have a choice to make, you know, every time. What the message I can't emphasize more is we have to really get on and do stuff fast together. Enough? You have to move on, maybe? Okay. One more question?
One to do with that guy farming in California. You were saying you reached a plateau with carbon at 6%.
Yeah.
And one thing I picked up on when I was looking at it was when he was planting his cover crops, he still had lots of exposed ground. And what could be happening is obviously sun can, you know, cause the carbon to release back into the atmosphere. So he's probably reached a plateau where he can't, you know, harness anymore.
That's correct. That's why, because he's starting to move into Notill, because his constraint, you see, is growing veg and fruits organically. So he cannot terminate anything with Roundup. So what he's trying to do is optimize his system, so he keeps his ground cover all the time, but the only way to do that is to move to Notill, really.
Yeah.
And so that's, at the moment, he's not quite there. That's his aim. That's why he's working with this network.
And one more.
Yeah.
About your inclusion of the 1 billion trees in the...
Yeah.
Yeah.
Yeah, I thought I would throw that in.
I was just interested in what your opinion on that is.
My opinion on that.
Yeah.
So the reason why I included in there is that sort of initiative is going to drive behavior and behavioral change, and some of this change might be positive and some of this change might be negative. So I do know that when you plant a forest, you're actually not stabilizing carbon. There's loads of data showing that, especially a pine forest in New Zealand. And at the end, you're keeping your carbon into your trees, but it's not a long-term stabilization of carbon. So it's not a long-term carbon sequestration, which is what the government is aiming to do. And the other thing is, Landcare Research is has been working for many years, and there's millions of dollars invested by the government to try and control invasion by pine, for example, conifers, and so on one hand we have signals that we have to control the invasion of exotic species, and on the other hand we have a license to plant these exotic species everywhere. So it's quite complex. There's some. I personally think that some of our farms would benefit a lot from considering a system like agroforestry, and that would work with this 1 billion tree. You could plant trees and incorporate them into your farm production. We've been speaking with some members of Quorum Sense about inviting Colin Merck, who's very good at predicting the role of native species and where they would grow and to fulfill particular ecosystem functions. So there will be something that could be optimized. What are the native trees or shrubs that could be planted in the farming system to increase the functioning of the system and to protect the diversity? There's lots of things that can be done. So that bill can be used well as well to create positive impact.
How does increasing plant diversity increase pathogen resistance? What's actually happening there? You might need to repeat that.
So someone was asking, how does increasing plant diversity increase resistance to pathogen, right? So when you increase the diversity of your plants, you're basically increasing the diversity of the entire food web that goes with that plant community. So you're increasing your plant community is supporting more diverse insects. Your insect community will contain a lot of beneficial insects. That's what Phil was doing by having a pollinator bank. Basically, he was farming those beneficial insects that will then attack the pathogen and the insect pest. The same happened below ground with your fungi and your bacteria. And so the idea is to get to a position where we're in balance, and if the whole system is healthy, there will be some pathogen there and some pests, but there will be enough beneficials that will keep these guys under control. Does that answer your question?
Is it?
Yeah.
Can I touch on that as well?
Yeah, sure.
So there's also a molecular or an elemental provision sense to that argument as well. Well, yeah, so when we look at, I don't know if you guys, who's heard of mycorrhizal fungi? Yeah. So that's an interaction between plants where they're able to communicate and exchange not only minerals but also water and carbon. It's what actually carries our carbon cycle. And so when plants are able to send out demands for certain elements for what they require to grow and be healthy and prosperous, is that through that diversity of plant species that are in that area, through that network of fungi, are able to send out signals and get in return provisions of what they need as far as elementals to elements and other, water and carbon, so that they can be resilient and thrive. And so that's what we're seeing when we're getting really, high levels of diversity. Is there's this level of symbiosis, and I believe possibly Simon's going to talk further on that. But it's quite a big picture, that one, isn't it?
Yeah, and when you apply no-till, for example, you're actually maintaining that web of fungi that is on the ground. So you're avoiding to chop them up. Some of the work I did before I went to New Zealand was looking at the connection between the trees and the shrubs in the boreal forest, and I found that they were connected by these mycorrhizal fungi, and they were exchanging carbon and nitrogen between them. Yep.
They're actually tested, they've done analysis on actually seeing physical movement and phosphorus, just to name one element. Is that you've seen that?
They've done carbon.
Oh, carbon, sorry.
Yeah, and nitrogen. Phosphorus is a bit more difficult to do, but we had a shot at it. Yeah, but if you give me more money. Yeah, good. Thank you.
Gwen Grelet, thank you.